and have been. I'm basically melting. The UK is still inside a massive heat wave, and it's gonna be fun. Oh, the temperature is not as high as like 3 weeks ago, but still pretty high. Hopefully, you are not hearing it because the filter is like making it's working its magic, but I have a little fan beneath my desk, so it will move the air and it will not cause it will not cause me to basically spontaneously combust. Ah. Hi, Big Dave. Welcome. Ooh. Yeah. Thank you. It was overdue. I constantly push back on going to going to the barber and getting my hair cut. And with this weather, it's definitely not recommended. So I had to do a little bit of work there. Oh. So last week I had to postpone the streaming basically for the entire week because I had to do like a bunch of preparation. My partner had surgery on Friday, so also this weekend was basically just playing nurse essentially, and I will have to do that for the next couple of weeks at the very least. So I think the streaming is going to be a little bit the streaming schedule is going to be TBD most of the time. I might also play around with the time, do some streaming earlier in the day or later in the day, depending on weather, availability, and whether or not outside is going to be a mess. English people do not deal well with warm/hot weather. They go slightly out of their minds, so there is a lot of noise outside. Hopefully it will all work out well, so we'll see what happens. But yeah. Just to avoid any issue, the surgery went well. Everything was fine. They're fine. They're recuperating. Like it's everything worked out really well. So there is nothing like urgent or specific or like problematic going on. It's just was just a little bit of surgery. Long tail from their earlier surgery. What was that, in 2018? So everything is fine. Okay, so what I wanted to do today was actually something that I thought of during the weekend, actually, in response to a discussion on Matrix, about the development with GNOME and the lack of tutorials, but also like being frozen in place and things like that. Oh, thank you, Div. Yeah, hopefully everything will get better pretty soon. But yeah, the basically one of the main problems that people have whenever starting with developing with GNOME is that they have no idea what to start with. There is a newcomers guide, and we'll see the newcomers guide in just 5 seconds. But there is a certain level of like there's a little bit of paradox of choice. There's too much choice, and if you don't know what you're going to do already, if you don't have a particular itch to scratch already, then it gets hard to decide where to start or how to start. And it's kind of brutal as an impact with a community, that you have no idea how to start, not just what to do, but literally you just in sensory overload, and you have no idea what's going to happen, and you have no idea what to do or where to find the stuff. Even the newcomers tutorial has issues, and those issues are kind of one of the reasons why the newcomers tutorial should be redone. I'm probably not gonna redo it like right now, but I wanted to do a stream where I basically do the most important thing in any like software developer's career. And it's also how you should start. Like if you don't know what to do, then you start with that, which is reading code. 80% of my time, in any professional setting, and also any volunteer setting, revolves around reading code that other people have written, or reading code that I wrote like ages ago, which is functionally like written by another person, and figuring out how things work and how they're put together so that you can understand where to work or what to fix or what to do when presented with a choice. It's actually one thing that I've seen a lot of artists and a lot of like creative people do whenever they are having some sort of like writer's block or some sort of creative block, where they don't know what to do, don't know what to do next, and don't know what to create next. The thing they usually do, a lot of people that are in creation of music or like writing or painting, like artists and things like that, they go and read books, listen to music, and like go and look at other artists' output, like watch a lot of movies or things like that, because that usually helps you getting over the block that you're confronting. So by giving you new ideas or giving you the idea of remixing or revisiting what other people have done, to give your own spin on things, or simply by saying, okay, this is great, I want to do something like that, I want to do something that is similar to what other people have been doing, that gives a certain vibe or certain response. And software development is very much a creative process. It's very much a creative art, even though we dress it up in a bunch of in a veneer of scientific endeavor. It's pretty much creation. It's like writing, it's like painting or making music. And the equivalent of listening to lots of music is opening up a bunch of software projects and reading the code and trying to understand what they're doing and see how other people have solved a problem or implemented something, and figure out, okay, I want to do something like that, or I want to apply that particular functionality to my own software, or I want to write something that is similar to another project. I want to give it a spin. And in the case of free and open source software, it also helps you just doing things like, I want to fix a bug, or I want to improve this particular bit of an application that I'm already using, which is kind of an interesting spin on like the art part of the creation, because you cannot just take something and improve it. If you take something if you take a piece of music and you want to improve it, then you create a separate piece of music. It's a completely separate endeavor. You cannot reintegrate that into the original. With free and open source software, you can actually do that. You can improve what already exists, and then present it to other users, and they will use the improved version. So it's a nice little twist that favors other people, not just you, in that regard. So being able to open up any project, read the code, understand what it does, and understand how it's put together, it's kind of a great advantage over the typical approach that is find the documentation, find tutorials, just copy and paste code until it works out, or until you understand how it's put together. That is typical of a bunch of other frameworks, a bunch of other platforms, and things like that. Here, instead of just having tutorials or just having the documentation, you can actually see something that works, and it's known to be working, and you can learn from it. You can not just learn from it, you can update it and fix it and make it better. So this is kind of an important distinction and an important part of the process of working on free and open source software. And I think this is where a lot of people just stop, because they're used to be able to just read a bunch of tutorials and not be confronted with the fact that there are other applications that are currently working, and that you can read the code and observe it into in a working state. It's also sometimes daunting. A lot of people think that you can take an application and you cannot understand it immediately. You have to basically just already be knowledgeable enough to understand it, to understand how it's put together, which is not entirely true. For some applications, definitely yes. You cannot just open the code base of Firefox and pretend to understand it like that. But that is an edge case. Most applications are understandable, because most applications are written by a single person or a couple of people, and the trick into maintaining an application is that you want to be able to keep it in your head altogether, and there are certain limits to how humans can contain an entire application in their head. And one way to simplify that is to reduce the complexity, to ensure that the application is simple enough that you can just take it and keep it in your head and turn it inside your head so that you understand every single piece. And if the size becomes the balloon out of control, the typical approach is to split it off and put the extra logic inside a library or something like that, and then at that point becomes an API that you can reason with. So again, it's all a bunch of techniques that already exist in the free and open source software world, and in general they help you in understanding the code base that you're trying to study or to work on. So let me switch to my desktop, and then we are going to go to the Newcomers page on the GNOME wiki. So this is the Newcomers page. It was written a while ago. It's nearly 10 years old, I think. It's definitely old. And it's also kind of a mess because it's a wiki, and wikis are, generally speaking, a mess. The obsession with wikis is kind of a thing. I honestly have no idea why. As a community, we kind of started like having wikis for everything. I think Wikipedia just poisoned the brain of a bunch of people. And so the end result was that we have a ton of documentation inside wikis that cannot be extracted anymore because wiki syntax is terrible. And we also have a bunch of stuff that didn't belong to a wiki, like complex UIs like this doesn't belong to a wiki, it belongs to an actual website. But the problem is writing a website is hard work, whereas a wiki is kind of simple, except when you get to this is terrible. The implementation of this inside a wiki is basically just writing pure HTML, like it's escaping a ton of stuff into a wiki, at which point you could have written an actual website. But you know, hindsight and all of the stuff. So let's assume you are a newcomer in GNOME and you are here and you decide, okay, let's contribute to GNOME. How do I do it? And you like bang your head against the community website and a bunch of other things, and you might end up joining the Matrix channel for newcomers, or you might end up simply just hitting the newcomers page. But you end up here, and it gives you kind of a flow. So you choose a project, you build a project, you solve a task, and you submit. Okay. Yeah, you don't submit. Writing submit is yes, submit yourself and you contribute. Yeah, this one should not like submit, but yeah, okay, it's fine. So this page actually started off ages ago when we didn't have Flatpak, we didn't have Builder, we still had Bugzilla, we still had Cgit for the Git repository browsing. It was pretty terrible. The introduction of Flatpak kind of simplified a lot of things. Before that, we had an entire page on how to set up a development environment, which basically consisted in download, clone this Git repository, which is called JH build. And you already have to understand like Git, you have to understand a bunch of stuff. This repository here will install, you have to build it. So you have to already have all the dependencies needed to actually build that project. That project is still using auto tools and it's terrible. But other than that, you have to set it up. And if you manage to set it up and you don't fail immediately at this very first step, you will have to run the script, download a bunch of dependencies that may or may not be up to date, in order to then clone a bunch of repositories from the GNOME Git server, build them all in sequence, and then at the end you will have a separate development environment that will not destroy your system. The caveat was that you, of course, need to have a very bleeding edge OS installed, so LTSs are out instantaneously. It only worked pretty much for Fedora and Ubuntu/Debian-ish, even those weren't like that great. So you end up with like having to fix the build of the entire GNOME, which is not great. Let me tell you that. As part of a release team, I can tell you that the building GNOME, like all the GNOME modules from Git, from the very bleeding edge branch, is not something that always works. And it's not something that always works even if you're a GNOME developer. So it's kind of complicated. So yeah, I usually don't recommend that either. But if you're building an application these days, it's a lot easier. There's Flatpak and there's Builder. Builder comes with Flatpak, so you basically just install Builder and it comes with everything you need. It's basically a turnkey development like environment, so you don't have to do anything. And a bunch of that that particular like set of instructions just went away overnight once we had GNOME Builder and Flatpak, which was good because nowadays it's a lot easier to get started. Still, you basically are confronted with this. So you start and it tells you to join the Newcomers chat room, which is good. Of course, you have to be patient and you have to be respectful because we have a code of conduct, and the code of conduct is important. Also, we're all volunteers here, so if you join the Newcomers channel and nobody answers you immediately because you joined on a Saturday or a Sunday, then kind of understand. But let's assume you have done all of this and you're good to go. So let's start. And now you're confronted with what the hell? Choose a project. GNOME has got hundreds of projects. GNOME is made of hundreds of projects. To make it easier for you to get started, we have highlighted applications that are great starting points for making your first contribution. Which is kind of a lie. Yeah, it's kind of a lie. Because this list here is not really maintained. It's maintained up to a point. Some of this stuff, some of these applications, these projects, don't really have the bandwidth necessary for mentorship, which is kind of important when you're like getting started. But yeah, like you have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 projects that are 13 projects that are now like in your face. And okay, how do I choose? Is there a programming language you like? You have the option of C, Vala, some Rust, JavaScript here, 3 in JavaScript, 1 in Rust, 1, 2, 3 written Vala, and 2 written in Python. And I honestly love the fact that getting things GNOME, project complexity, simple. No, it's not simple. It's a complex application. PTV, project complexity, medium. No, it's a very complex application. It's a it's a video editor. It's a complex application. Here, photos, project complexity, medium. It's written in C. It's not medium. It's automatically complex. GNOME Music is not a simple application. Polari is not a simple application. Maps is not a simple application. I mean, yeah, Sound Recorder is simple. I mean, I appreciate the fact that at the very least, Nautilus is listed as a complex application. Also, Boxes is listed as a complex application. Ironically speaking, Boxes is less complex because most of the complicated bit of code is inside libvirt, and libvirt is very, very complex. But Boxes is a fairly simple UI on top of that. Of course, the complexity is how to manage the simplicity, which is kind of a thing. Oh, hi, Alatier. They were great 5 years ago. Yeah, they were 5 years ago. Like Connection is a spin-off of Boxes, and technically speaking, yes, it's a medium complexity application. So if Boxes is complex, then Connection should be complex as well, because they are both kind of, they're not similar, but they are kind of, they use the same approach. So a complicated underlying library and a UI that is not simple, but well designed on top of that. Fractal is not a medium complex project because it's a chat application that talks the matrix like protocol. I would never say that it's a medium complexity. GitG, it's kind of medium complex. Yeah, as I said, the Sound Recorder is actually the correct. It's a simple project. It's not simple because it's simplistic, but it's simple because it does one thing, and it's very much written around other complex libraries like GStreamer and libadwaita GTK. I would never say that Maps is a simple application. Maps is a fairly complicated application, like anything related to Maps, even though it's a UI based on top of a another library that deals with most of the mapping kind of bits. It's still a fairly complex UI because this is the old Maps. They're still using like GTK3 and Clutter, so not super simple how it's put together. Clocks is a simple application, I'd say. So it's simple in the sense that it's mostly UI. The underlying functionality is very much abstracted away. The main complication right now is the work clock, because it's based on gweather, and gweather had to move out a bunch of the UI bits for the port to GTK4, which means that there is more logic inside GNOME clocks than there used to be, especially when on the UI side. But again, it's I'd say that it's a simple application in terms of complexity. So you are confronted with this and you are basically like frozen in place. So you end up with a programming language you like, or maybe there's an app that you use yourself. And that's it. That's it is kind of condescending, but yeah. Again, the problem is sometimes people are not just starting to learn how to develop with GNOME or for GNOME or with GNOME, but also they're starting to develop with a specific language. So it's not immediately obvious how to deal with this stuff. But yeah, let's assume, okay, we want to start contributing to sound recorder because it's written in JavaScript. I know JavaScript. Spoiler alert, I don't really know JavaScript, but let's assume that I know that I'm well versed enough with JavaScript that I can do that. Because the only other option with JavaScript is Polari, which is an IRC client, and if I were to be a newcomer, I would have no idea what an IRC client even is. And maps, I'm probably, that, as I said, it's a little bit too on the complex side. Sound recorder sounds simple. So we'll start with that. And so we get to build the project. So you get to the latest software, that's fine, get Flatpak, and note for Ubuntu user install a package called Tracker will be necessary for most of the apps. Okay. And then you download Builder, which is using the old icon because, and the old UI, because of course this has not been updated in 3 years. Great. So let's actually start like this. Start new project. No, here. So one of the things that is actually pretty useful is that GNOME Builder comes with a list of suggested GNOME projects that lists the language that it's been used, and it gets you going pretty easily. It's actually a lot more useful than it's actually a little bit more useful than the wiki page, to be honest with you. I would replace that entire bit with, okay, let's get you started. Install GNOME Builder. Okay, launch GNOME Builder and go to the suggested GNOME projects, and here we are. That would be a lot easier probably. So also because it shows you that what you think is like maps is written in JavaScript with like a simple project, it's actually a mixed environment of C and JavaScript. So you were lying. Some of the things here are not entirely correct. Like for instance, calendar, it should not be inside this list of GNOME projects because it's there are no mentors available. George's is great. It can maintain a ton of projects, but it cannot like clone himself. So it cannot maintain a project and also be a mentor for it at the same time without basically just going insane. Like most of us. I mean, it's hard to be a maintainer and also work as a mentor unless you have other people like contributing to the code base, in which case you can just be a maintainer and occasionally code, in which case you can also mentor other people. But these days, GNOME developers are stretched really thin across the entire stack. it's not just GNOME, of course. It's like it's a shared burden across free and open source software. There is just too much to do and not enough people to actually do it. Back in the late 90s, early noughties, we could go toe to toe with large corporations with just a bunch of volunteers because the expectations were low. These days GNOME is competing with a couple, like $3 trillion companies like Apple, Microsoft, and Google in terms of UI or user experience for like devices, for computing devices. And we're doing that with like, I don't know, 300 people, 300 volunteers, basically. There are a bunch of companies that employ people that work on their projects, and also those projects are based on GNOME tech. That doesn't imply that they are working on GNOME. And yeah, it's not just expectations, of course, and everything is much more complex. The bar for like a computing environment is a lot higher these days. Also because those trillion-dollar companies employ and use open source software as well, because of course they do. It's economically, like, it makes total economic sense, which means that they get to piggyback on what we have already done, which also means that we are basically competing against ourselves. Which is why everybody that says, oh, GNOME is competing with KDE, or KDE is competing with GNOME, or with XFCE, or whatever else, it's just they have absolutely no idea what they're talking about. They're too young, or they're just not involved in like software development at all, because we're not competing out with each other. It's just not what happens. We're competing with the big boys. Multimedia is going to get so much more complex that I'm worried. Yeah, that's going to be a problem. Also hardware support. The latest Dell laptops, the XPS ones, they have done what Apple did for the webcam on their MacBooks. So they changed the way webcams work, which means that if you buy the latest Alder Lake Dell XPS, the webcam will not work with Linux unless you're running Ubuntu, and Ubuntu is basically just patching the kernel downstream, because there are no drivers upstream. And I think for a while, for the past 10, 15 years, we've lived in a island of relative calm and relative standardization, but I think we are moving past that, especially in the hardware side. We are gonna get a lot more hardware that requires specific drivers, specific firmware, and I don't know if we are gonna be able to keep up with that at the same level in the generic Linux. So that is gonna be a problem. If we ever want to do something like Atmos Spatial Audio, we need a team of physicists, audio engineers, and software developers. Yeah, of course. Yeah, basically a lot of the specs for like complex functionality are completely out of the reach for volunteers, and new hardware is getting a lot more computers inside it, It's computers all the way down. Computers like there are computers inside your computer that are inside your computer, and all of them, they are managed by software that you have no idea how it works or where it resides or whatever. So I think the island of stability that we benefited in the Linux, like generic Linux desktop, is coming to an end, and it's going to be problematic there. It's going to be interesting to see what happens there. I'm not entirely confident unless we manage to get somebody to pay for a lot of this stuff. Hardware enablement is always going to be a problem, but it's becoming more complicated. Up to a point. I mean, for some stuff, it's going to be like talking on some wire to some other computer using a protocol. Who knows? Maybe it's going to be enough, but you're going to be talking to a computer you don't actually control. So you never know what's going to be doing behind your back. Camera model on Pixel phones around Linux kernel. Yeah, of course. But even like, I'm not even gonna talk about servers running their own little computers that are gonna boot up your main computer. So who knows? Okay, we were saying, let's go with the sound recorder because it's JavaScript and it's really JavaScript. So there are no like additional things that lurk in the background. So we have a repository URL already set, a project destination already set, clone the project, and we let GNOME Builder do its magic. And we are inside it. And this is like live. I'm not doing this like this hasn't been scripted or anything. I haven't seen the sound recorder code base outside of the web browser for like ages, so I have no idea how it's done or it's put together. So usually the first thing I do whenever I am confronted with a new project that I have no idea how it's put together, the first thing I do is look at the build system. I recognize this might be a fetish of mine, but I usually go for the build system because how do I say this? These days, build systems are actually tractable. So you can always start with this and figure out what goes where, what are the pieces in play, and how they are assembled together without actually going insane or actually going into the code base and figuring it out. So this is pretty much, yeah, it's fairly like standard stuff. You get a bunch of directories. This is a little bit of mess and magic to get the application ID depending on the profile. This is not great. I'm already going at this and they're like, this should not be done this way. This should be like this. Because sound recorder devel is kind of bad. Should be sound recorder.devel, but it's fine. It's fine. It's fine. I'm not gonna change it. But yeah, if you if you want a very low friction kind of introduction to a project, working on the build system, it's usually a good plan. It's a good plan because in the case of Meson, I'm not going to even go like auto tools. If a project is still using auto tools, porting it to Meson is usually a way to make the maintainer like love you, because it's a great way to speed up development. It's a great way to make the build system tractable. It's a great way to make your development environment a lot simpler to deal with. And the same thing happens when you fix the build system. You like make it more consistent with other applications, for instance, or you simply decide this is using like an older version of like idiomatic Meson. This is the new way of doing things. So starting with that, it's usually a great idea, because people don't like maintainers do not, generally speaking, like dealing with the build system. The build system is a pain in the ass. It's just a way, it's just something that is needed to get your software to build and be deployed somewhere. And yeah, it's not great. It's definitely not great. So if you want like an into any project, just go over the build system, figure out where it's using like older Meson like idiomatic code, and fix it and update it and use a more recent version of Meson, for instance, or things like that. Document it, improve the documentation for the build options, things like that. Usually it's great because, again, it's something that maintainers tend to not to look after it's working. And if it's working, they don't touch it, which means that it can go, it can bit rot. Like, for instance, GNOME Sound Recorder right now, it's depending on Meson 050. Meson is 063 now. So this release here is from like 2 years ago, probably. Yeah. So 050 is from March 2019. So it's from 3 years ago. So definitely maybe bump it up to 060. It's a good idea, at which point you basically can do things like removing deprecated stuff. Like here, for instance, is another thing. It's using source root, which is a deprecated method, and it's using the uninstall script, which has been replaced by GNOME bit inside the GNOME module inside Meson. So it's a great way to like remove a bunch of stuff here. But yeah, this is as I was saying, this is a great way to start. This is a great way to get the ball rolling, because as soon as you see something like this in the build system, you kind of get to the point where, okay, I can fix this. I can understand how it's put together, but I also can contribute to it. And it's the contribution that drives the feedback loop to get you interested into something. I know that a lot of people just start by saying, okay, I want to contribute like new features or new things. Instead, you should start with this, contributing with the maintenance of the project, contributing with the development quality of life, the maintainer's quality of life. Because once you do that, then you get the ball rolling, you improve there, you improve your knowledge of the build system, you improve your knowledge of the application, and so on and so forth. So let's try and build it. Like, for instance, here, when building it, you already get a warning here, and you get a notice that there's a deprecated feature being used. There are two deprecated features being used that were deprecated in 0.56, and we are using the latest version of Mason, which is 0.63. So yeah, the build of course succeeded pretty quickly because this is a JavaScript application and it's pretty easy to run, pretty easy to build. So let's get started. Newcomers generally don't know how to build and run the app manually, let alone understand build system. That is true, but it's actually a good strategy to start. You're literally running this and you look at the build log and you realize, oh, there's something like that. And it's, I mean, I'm kind of I may be biased a little bit because this is how I started contributing to GNOME. Like fixing this kind of stuff, but I wasn't knowledgeable at the time of anything that happened in the UI, and a lot of people are just frozen in place by the choice, and this is a good place to start as any. Adding functionality, you get the how do I add a UI? I have to contact the design team. I have to design something. I have to like discuss this with a bunch of other people. I have to build things. Then it's just, you can start from simpler things. Like in this case, the build system is pretty simple because it's telling you what is wrong with it. Which is one of the things that I appreciate about Mason. It's just that it's telling you how to improve your own code. It's not like cargo clippy levels of improvement, but so yeah, why not? Build so let's look at the build log, which has been conveniently changed by builder because of course I changed branch. Clean it, and we build. So first thing first, source root is a deprecated location, deprecated method. How deprecated is that? Well, it's fairly deprecated. Let's build. We go here and look, source root. And we get this. Nice. So build root and source root are deprecated. This function common source of issue when using some projects. Okay. We use current source dir or current builder or project source root or project build root. So what are we doing here? This is the location of the translations. It's a pod directory. Assuming, okay, we have no idea what the pod directory is. There are a bunch of PAW files here. Let's see the ngb PAW. It's translation. Okay. Yeah. So these are translation files. This is used in other places to determine where the translation is, I guess. So, well, I don't guess, but I'm approaching this as a complete newcomer. So podier, let's look at podier inside the meson file. Okay, so data. Let's build. And yep, Podier here. Merge file. So we still go here. This is a module inside Meson. Merge file is here. And Podier, the directory containing translation relative to the current directory. So it's a relative to the current directory, which means that here we are defining the position of the PO directory from the root of our project. So we use project source root, which is perfectly fine. So we rebuild it, and it will tell us, oh, you are using project source root, which has been introduced in version 0.50, but 0.56, but we are depending on 0.50. Okay, so we are gonna do this as well, and that's great because now we are just using a deprecated one. And now it's also telling us that there is a warning here because I'm using a function feature deprecated here. And it's telling me how to get around it. So, okay, we're fixing this. So let's add this here. And we commit it. Replace deprecated Meson source root. Use Meson project root instead. That's it. Then we also have another one. Where was it? There's a check. Oh, yeah, need to. Okay. So we have another warning here. Meson build 35. Project targets 56, but use a feature dependency get package config variable. Line 35 here. So this is getting a dependency object for GJS, and it's asking to get the variable here GJS console. So I assume that, yeah, same version as well. So dependency get package config variable is being replaced with get variable, as the warning in the console is telling us. Use dependency get variable package config. So here we replace it, get variable package config here, and we rebuild it. And yeah, great. We don't have anything else. So we have another, well, we can add again Meson build. Build is deprecated get package config variable. Use get variable package config. And we also now commit change build depend on Meson 0.56. Remove we are now using non-deprecated API. We also have another problem here. We have a warning here. You should have Boolean check argument to the run command call. We have a run command here, and we should check because of course we want this to fail if there is no git installed. So now we rebuild it, and great, there are no warnings here. Perfect. Fail if the command fails. Deprecated typo in commit message. Oh, great, thank you. Yep, this one. And yep. And this is great. We already have like 3 commits on a branch, and we haven't even touched the actual code base. We just fixed deprecation warnings and actual warnings inside the build system. It's a great first contribution to a project. It's just an introduction to the project itself. It's just, okay, here's a project. The project is open to contribution. I've noticed that you have like a little bit of problem on your driveway. There are somebody thrown like a bunch of paper in front of your house. I'm gonna pick it up and put it in the garbage bin. And I didn't even get into the house. But we now have an actual working application. A working application that has a bunch of critical warnings. Ouch. Yeah. These are bad. These are actually bad. I mean, if I'm putting my first contributor shoes on, and I'm just noticing a warning here and like 3 criticals here. The fourth like warning here is, I know what it is because yeah, it's the accessibility stack is kind of problematic in this regard. These 2 are from the type system, which means they are very likely coming from the language bindings. I do hope that the GJS maintainers are aware of it. And there is a warning here. Oh no, GST plugin scanner. This is coming from GStreamer. What the fudge? And this is coming from GStreamer as well. So I do hope that GStreamer developers are aware of this. Anyway, this is pretty fine. and you get the latest bit. Great. So we have a working application here. Should I stay offline? No, now you understand. Every time I see something related to GTK in a stream from like George's, I'm like, oh god, now I have to look at that. Not only that, every time somebody posts something on Discourse or somebody posts something on the Newcomers channel, I like see this. Like, oh, there's a critical from GTK. Damn it. Okay. So, okay. Let's see the project layout. How it's working out. Yeah. The Mason build here, at the very bottom, there is an install script. Inside build AUX, there's a post install script. Okay. What does it do? Why is it creating a bin directory? Oh. This is nasty. Okay. Yeah, I understand why it's doing it, but we shouldn't be doing that. This is literally only gonna work on like Linux, and it's creating a link, a symbolic link. Oh yeah, because the binary is called or GNOME sound recorder, and you want a version. Yeah, why? Anyway, yeah. The nice bit is that all of this can go away. This, and this, and this can go away. Everything else can stay. Like this one can, like, this isn't really correct. Like from a packaging perspective, this is incorrect. Because it's creating a link regardless of the destier. I'm shocked that distro packaging isn't just coming down on this. I assume that nobody noticed this. But yeah. So all of this can go away. Because then we can do this. Well, run the GNOME module, post install. We require GNOME 57 actually. So I can do post install. And we want glib compile schemas. We want GTK update icon cache for our icons, and we want update desktop database because we are installing an application. We don't need query modules. This one, no, this one requires 59. So we actually gonna need this to be 59. So if we do this, we need to rebuild. Okay. Oh, we don't. There are no critical warnings anymore from GStreamer, probably because the cache, the module cache, is in effect now. But yeah. Yep. This is another build bit. So what I've done here is I replaced a custom bit of the post install script with functionality that was subsumed into Meson proper in the GNOME module, which is the compiling the G setting schemas, updating the icon cache, and updating the desktop database. So now the install script, the post install script that Meson, well, that the sound recorder employs, is going to be just doing just one thing instead of being doing a bunch of things. And we also add a comma at the end, and here too. And now we can commit it. So build use GNOME post install instead of putting the post installation bits for schemas, desktop MIME entries, and icon cache. We can use the GNOME module inside this one. Which will check the binaries we depend on and will do a better job at keeping up to date. So yeah, these are just a bunch of, again, quality of life improvements for the maintenance of the project. So again, reading the build system is a great way to understand how the project is put together. For instance, here we have a data directory that contains the icons, the resources, which are screenshots for the application data here. And then UI files for the UI, of course. And style classes for CSS. Okay, this is pretty standard fare. We have a lint directory for, yeah, our linting process. I guess it's part of the test suite, the CI pipeline. We can look at this. Yeah. Yeah. The CI pipeline has ESLint job, which does a bunch of reports and presents them on the pipeline UI, on the merge request like user interface on GitLab. So it's perfectly fine. It's not important to the code base. It's important for the rest of the development process. We already seen what build auxiliary does, which is great. We've seen what the PO directory contains. And now we have the source code. Source code is all inside one directory, which is good. It's a lot easier to grasp. So let's look at the build here. We have a file that is built at configuration time. It's installed inside the package dir directory, and there's a bunch of substitutions here. One of them is GJS, and the other one is the application ID. If I had to guess, this is our main entry point, which is actually correct. The imports package bit is something that is provided by GJS itself, as far as I know, and it's just GJS is kind of a weird thing. It used to be very plain, just a simple wrapper. You had to basically do everything yourself. Then at some point, it started including a bunch of wrappers to make it easier to write applications with JavaScript. And one of them was the package module, which basically sets up the environment for you. So you basically just specify the name of the application, the version, where it is located in a couple of places, and then you run the main, which is here. You have to do a bunch of things like initialize the getText. getText is the localization API. Formatting strings probably, and these are the modules that are required at runtime. Of course, JavaScript is not going to be compiled, so you have to declare your dependencies in a different way than you would do for a C program, for instance. But in the main Meson build file, we see that we check for the dependencies at compile time, so that the configuration will immediately fail if these dependencies do not exist. It is kind of a overkill in a sense, because you don't really need the development files for these dependencies in JavaScript. Most downstream distributions, including Flatpak, will include the binary data that the GJS consumes to provide the bindings, alongside the shared libraries that are used. So the introspection data for GIO and GTK4 and GStreamer and libadwaita is going to be available alongside the actual shared library. Whereas the dependency here are for C dependency. So not just the shared library and the introspection data, but also the header files and the package config file for compiler flags and linker flags. Again, a little bit overkill, but this is how it's done. We don't have in Meson a way to declare a dependency for GJS, for instance. It would be interesting to add that functionality, like an introspection. Instead of asking, I'm asking GIO 2.0, but introspection, I will just want the introspection data. So I will look for the introspection data in the general directory and will not depend on that, depend on the C bits for if I'm not using them. But at the moment, there is no such thing. So still, if you can satisfy all these dependencies, your JavaScript application will build by definition. So yeah, let's go back into the main. The main imports application and instantiates it and runs it, which is our main entry point. Oh, nice. Okay. Gonna start new goal. It's FFmpeg. Of course, it's FFmpeg. It's always that. So let's go inside the application here. We have an imports here, so imports application. This is definitely this is where things become interesting. So first of all, we import from GI. This is using the old import notation. The new one uses I think it's the node kind of syntax with the fake URL kind of thing. GStreamer fails to register some types with invalid type names with FFmpeg 50. Oh, great. Thank you, Alatier. Okay, so yeah, we can already see that while this application is using like the latest libadwaita and things like that, it's also not using the very latest GJS idiomatic code. It's using the previous iteration of the of GJS like idiomatic like approach. So we're using the old version, like the old import syntax, a bunch of all older things there. The init here should be a constructor. But yeah. Like spoiler alert, I know this has been fixed upstream. There is a merge request that fixes it and switches a sound recorder to TypeScript even. But I'm not gonna fix it, man. There would be no point in me fixing it. Also because, as I said, I'm not a JavaScript developer, so I know how to read it, but I'm not confident enough for like porting this to the latest JavaScript. So here we have the imports. We have some global definitions like where the recordings go, the cache, and the settings object, which gets loaded using the package name, so the application ID. We have the window object here, which is defined in this object here, and then we register a class for the application. So this is pretty declarative at this point. We initialize the instance, we set a bunch of properties for pulse audio. Jesus. There are right, yeah. So this is quite interesting here. So GTK application and G application, which is the base class upon which it's based, have two ways of handling command line options. One of them is I create an option, I create the instance, and I parse the command line option. I parse them. I parse a bunch of the command line options before the instance creates a name on the session bus or contacts the currently running instance of the application that owns the name on the session bus. And then we have a bunch of we pass the surviving options to the currently running instance if that is that exists. In this case, we intercept everything before that, and we check if the options dictionary contains the version command line. in which case we print the version and then we just bail out immediately. This way, we don't have to we can run GNOME Sound Recorder -- version on the command line without having to contact the currently running version or even setting up the running version. So it never reaches the point where we activate the entire thing. It's a choice. I mean, it's the version command is a good choice, but it's a choice. Okay, so here we are creating a bunch of actions, which is the typical place where to put them, which is the startup here. The startup virtual function. We initialize GStreamer. We create the cache here and the recordings directory. If they already exist, we bail out. But if the error is not if we only error out if the error is those directory already exist, because of course. And we initialize the application menu, which is create a bunch of actions here and install the accelerators. Profile action, create action here. Okay. Utils. Let me check. What is settings? Oh yeah, sorry. Settings is a gsettings instance. It looked like an ancillary class, but it's not. So we are doing geosettings, create an action for the audio profile and the audio channel. So whenever these settings change, an action gets emitted, which is fine. This is simple action. When it's activated, we show the about dialog, and whenever we quit, we close the active window. So that's fine. Inside the activation, we create a new window and we show it. That's it. And the show about dialog creates an about dialog here, pretty standard fare, and we show it. Yeah, this is fairly simple, but there is not much. There's not much here. There is a lot of code, but there is not much here. It just sets up the application instance, and basically whenever we run it, we initialize the underlying libraries and we initialize the state of the application. Okay, so it's pretty simple stuff. Now we're going into the nitty-gritty. Okay, so we have our main window application. So here, so we run it and we activate it, and we have our window here. So the window has its own UI. Here it's part of a G resource, so the UI is going to be here. And we have a bunch of stuff here. Okay, so we have the primary menu. Where are you? Here. Okay, this is where the audio profile stuff is. It's a radio definition. So here, preferred format, and here we are with the various formats here and the audio channels here. Okay, so these are mapped directly to a G settings. So whenever the property changes, whenever the preferred format changes, it gets copied into the G settings for this application. Let's look into the G schema here. Yep, there's an enumeration, audio profile, maps to a integer value, and then we have the audio profile here. Maps the media types to audio encoder preset names. Yeah. And same for the audio channel, stereo or mono. That's fine. So yeah, this is fairly standard fare. It's fairly standard fare in the sense that this is as idiomatic as it goes. You map a string, which is the action parameter, to an integer, and you store the integer, and that's it. Well, you don't store the integer. In this case, you store the string, but that's pretty much the same thing. There's still a window position. Oh god. Oh no. Let's see if something uses it. No, it's just there. Okay, good. Let's see. I don't even see the saving the window size. Let me see. Window size. No, it's just there, but it's not stored anywhere. Okay. Hi, Jakub. Welcome. Right, for those who just joined, I'm just reading the code. I'm going through the sound recorder code base, the GNOME sound recorder code base, as if I were a newcomer, a new contributor. And mostly I'm showing how, in this case, a JavaScript application is put together, a working one, as some sort of tutorial. In general, the overall idea is figuring out how things are put together so that you can either replicate this layout, or if it's not idiomatic, if you want to start contributing, making it idiomatic is a great way to getting started with writing code for GNOME and contributing to GNOME. Taking something that maybe was written like years ago and it's being kept up to date but not to the bleeding edge, and figuring out how to make it more idiomatic or make it fit in with the very latest guidelines for like the build system or the language binding, like in case of JavaScript or Python or whatever, and so on and so forth. So the window here imports a bunch of stuff, which is perfectly understandable since it's where we are going to present our UI to the user. Hi, Georges. Okay, so yeah, this is, yeah, there's a new recorder widget and a new recorder here. The recorder is probably, just going on a hunch, going to be the engine, and the recorder widget is going to be the presentation. It's all added inside the stack, which is the main stack here, and in the UI file, it's here. Yeah, there's a main stack. There's 2 pages, empty and recordings. And the stack page for the recordings has a scrolled window, a viewport, and a clamp. And then we have the empty state, which is the initial state, which is this one. There's a status page. Add recordings. Use the record button to make sound recordings here. Yeah, this is exactly what it says on the tin, and the other one has a list of recordings then. So it has a list of recordings. It will have a list of recordings. So let's go back to the window. This is GStreamer gobbledygook. Yeah, the player. Right. We have a list of recordings, which is a list model, because it has an items change clearly. And then we have a recording list widget here. And we set the help overlay here. Why is it doing this? This one should be done automatically by the application window. Oh, I know why it is. Let me double check. No, it should be fine. Yeah, I don't know. Maybe it's just... So this bit here should be done by the by GTK application window, by GTK application window themselves. The help overlay is automatically found inside the resources for the application ID, and it will be called set help overlay automatically. I think this is something that stayed there after some change. So we are going to do the other most important git command you will ever learn outside of git commit, which is git blame. So Bilal changed this in 2020. When he added all of this. This is pretty interesting. Why did he do this? Yeah, it's been in 2020 here. The alias is fine, should be okay. I don't understand why it's done like this. What happens if I do this? So we do this. We stop it and we relaunch it. We do this. keyboard shortcuts, they still work. So this is unnecessary. Because GTK will do this for you. Let me double check. Yeah. Okay. We are going to switch to another branch. Okay, experiments. Because the previous branch, I'm gonna open a merge request for it, but this one is mostly for experimentation. So we can commit remove unnecessary help overlay creation GTK application window will do what? And will be overlay automatically if one is found at the right place in the UI definition file. This is a great commit because it removes 3 lines of code. Rule number 1, deleted code is maintained code. We have another action here. We have a recorder widget that represents state. And it has a recorder action group because, yeah. So the UI file that we've seen here has a bunch of actions. No, not here. Not the UI file. The application here has a bunch of actions that are under the namespace recorder. Record start, pause, resume, cancel, stop, and then we have a recording here, play, pause. I have no idea why. But yeah, so these exist in a separate action group instead of being inside the window or the application action groups that are created automatically by GTK. In theory, there is no need to create an action group like this to insert an action group here. The recorder widget could create its own action group using the GTK widget API. But the GTK widget API uses the widget class pointer instead of using the instance pointer. So I'm not entirely sure that it's doable with JavaScript. Maybe. But yeah, idiomatic GTK4 code would be logs GTK or GTK4 class widget. Class method here. Yeah. The idiomatic way of doing that inside GTK4 would be using GTK widget class add binding action. So you, instead of having all of those bits and like creating an action group and then inside the application defining the accelerators for the action, you basically would define it here and do the various bits and pieces yourself. and then use install action, for instance, or use install action as well. And you do that on the actual widget you're doing this stuff. In this case, you don't want the focus to be on that widget probably, so you give the focus to the window and the window handles it. It's, yeah, it's questionable. There are too many ways to do this, and this is the reflection of how do I say this? This is the reflection of an evolving API. We had the original API that used the action stuff here, and the reason why that happened is that this was written in the early days of GTK 3 and the early days of GTK application, G application. At the time, we wanted to have the menu structure and the various actions to be some sort of API for an application. The reason why that happened that way was that we wanted to expose the menu structure of an application over the session bus so that other components like the shell could take it and present it to the user. But also it would work for other platforms like macOS, where they have the global menu, and they have a global menu for each window and each application, and that means that you have to be able to describe your menu structure and the way to launch your application separately from the actual widgetry. Of course, in GTK 3, we still had the widgetry, and a lot of people just built menus out of that instead of building them out of actions. In GTK 4, I made the proposal of just dropping the widgets. You can only describe menus in terms of the GMenu API. So you describe them, you describe the structure, you describe what happens when a menu gets activated, a menu item gets activated, or a sub-menu is opened. And the widgetry is done internally by GTK, and you don't know where that happens or how that happens. Because in theory, it could happen outside of the application's process, for instance. So let's assume on macOS, you have a menu structure. The menu structure gets sent over some wire and gets rendered by an entirely separate process. It also used to be the case with the application menu for GNOME Shell. It also used to be the case for Unity and the global menu inside that. Those ideas have somewhat fell out of favor these days, mostly because by and large, complex menu structures are a thing of the past in GNOME. Which is not to say that menus are a thing of the past. A lot of applications are still using menus, and they will still be using menus. But those menus will very likely stay inside the application and not move around, except on macOS. That is a fact of life, and we cannot do anything about it. And in some sense, the action API is kind of too limited and at the same time too open, to the point that a lot of people are complaining about it. So we'll see what happens with GTK 5 at this point. But yeah, GTK 4 inherits some of the decisions that we made with GTK 3. It removed a bunch of stuff that was not good enough or was too introduced too much flexibility in how menus were structured. Sorry. And the end result is that there are a few ways to do this thing, that is key shortcuts and accelerators and actions that are specific to a widget or specific to the application. And yeah, sometimes it's hard to figure out what to cut and what to keep and what to improve. Hi Federico. Has GNOME ever thought of using formal methods for the verification of some of its core components? No. Formal methods of verifications are useful in two very specific ways. One is academia, and that is just not interesting. And the other one is business, like enterprisey software. It's usually easier to reason in terms of formal methods of verification for self-contained services that either talk to other components via well-specified channels. For a GUI application, I think it will be a lot of effort for very little gain. But to be fair, we also are having problems with UI testing at the moment, so I think in many cases just nobody has ever put the effort in. I personally would not put any effort in any of this, but if somebody wants to try to do like formal verification for like an application or a simple component, like I would start with something self-contained, like the GNOME settings daemon, for instance, or like dconf for the settings storage, or GNOME session, for instance. So something that it sits at a very low level and only speaks to other components via well-specified like IPC mechanism. Thankfully, no cars rely on dbus for controlling any component. Oh yeah, of course. Yeah, thankfully. And thankfully, no car exposes please run this as root interface that is completely unsecured. Yeah, of course. Who would do that? Okay. So we have here a TODO fix recording key bindings. No idea what it means. If you leave a TODO, please leave a TODO that doesn't make sense just for you. Please describe what you're doing. If you leave a TODO, either link an issue inside the comment or describe what you need to do. Because if you haven't gone around doing it, chances are you will not, but somebody else might. So you're not paying comments by the line. You can explain what you want to achieve inside your to-do comment. This is a feature that I really love about GNOME Builder. GNOME Builder will automatically just scan your source code for comments like to-do and FIXME. And here we have a FIXME that says remove by 340, 342. And there is no GNOME 30, GNOME 40 or GNOME 340 and GNOME 342. These would be GNOME 40 or GNOME 41. Yeah, I guess this could be removed at some point. Well, at some point, very soon. There's really no point in doing this. Unless somebody like started GNOME sound recorder in GNOME 36 and recorded a bunch of stuff and then completely forgot about it and then rerun it again in GNOME 43, which is entirely possible, but also if you didn't bother doing that, then you probably are not going to be bothered doing that anymore. But yeah, this little utility in GNOME Builder is very, very useful, especially if you want to explore the code base. Assuming that the maintainer decided to mark stuff with TODO and FIXME and things like that, which you should definitely do that. Always leave comments. The comments are not for you. They are for you 6 months from now, and you will be a completely different person, or they are for completely different people. In which case, okay, so yeah, we were at the window. This is all set up. This is close request. It's tearing down stuff, setting the pipeline for everything down, stops the recorder, and quits the application. This is technically speaking unnecessary. Wait, what? Why is it doing this? GTK window. So this is a vfunc close request. Close requests returns a oh, this is a bug. This is a bug and nobody noticed it. Yeah. Yep. This is actually a bug. The close request virtual function has to return a Boolean value. But nobody noticed it because calling the quit method on G application will automatically terminate the process the next time the main loop spins. So at the next iteration of the main loop, GTK application will quit and terminate. This is also kind of an interesting thing. This is an interesting bug, actually. So closing the window. So technically speaking, sound recorder can have multiple windows like lying around, because the activate implementation here in the application will create a window. Oh no! Oh no! Yikes. Okay, no, ouch. So if you have running if you have sound recorder running and you activate it again, so you launch it again, it will close the current window and will replace it with a new window. Because this one should be if this window or it could be if not this window. Like this. Yeah. Otherwise, yeah, it will close the existing window, create a new one, which is does exactly the same thing, but it will tear down a bunch of state and restore a bunch of state, which is why window here will call this application quit, because if it didn't do that, as soon as you close the window, it will terminate the entire application, so it will close all the windows. Oh, so this is a pile of bugs that are masking each other. This is so weird. What are some GNOME protocols which one could try to formally verify? Well, the main protocol, it's all like dbus. So you have dbus as a wire protocol, and then you have a bunch of interfaces built on top of that. There is nothing else really for IPC at the moment. I mean, as I said, I personally will never spend any time doing any formal verification on GNOME. It's too big of a project. If you want to do like formal verification on a single a single component, then I would look at a very small component that probably sits in the middle of a bunch of other things, that is self-contained, and it's only accessed not via an actual API but via IPC mechanisms, at which point you can say, okay, everything inside the IPC mechanism outside the same process, outside of that process, is an out of boundary like condition. It doesn't matter. And then I verify that whatever happens in that particular component in response to like external IPC calls is valid, and it can be formally verified. Otherwise otherwise you start like formally verifying that the dbus wire protocol is correct, and then you start to verify that gdbus, the API that we use, is formally correct. At which point you have to start to verify that verifying that gobject is formally correct, and then it's layers of layers of layers. It's a lot. So that is why I'm trying to say try to isolate at the IPC boundary, and everything that happens outside of that boundary is not important, or doesn't need to be formally verified now. Instead, you verify everything that happens within the process boundary, and that means that when you get like a dbus method gets invoked and you respond to that dbus method, you assume that the method is correct, and you say, okay, this method has been verified somewhere else, it's fine, and my response to that, I can verify that. So yeah, as I was saying, like dconf is probably a good idea to verify if you assume everything is correct. GNOME session is another one. The GNOME settings daemon. They are a bunch of daemons. They're a bunch of like components that talk to each other via IPC mechanisms. So yeah, there are layers, and you don't want to like start like with formal verification of something, and then you suddenly have to formally verify that GObject is correct, because then you're in trouble. Okay, so this is an interesting bug. Yeah. So here is okay, source application. Do not overwrite the existing window on activation. Sound recorder only has one window per instance. So if there is an application window open already, we don't need to do anything other than presenting it to the user. And then here, fix the close request desync implementation. If a window class close request returns a Boolean value. True for swapping the signal information, false for continuing. Okay, the default behavior when closing window is to destroy it, which will terminate the application instance. The lack of a return value was masked by the explicit call to G application quit, which forcibly terminates the application. Next, name loop iteration. This was a fun one. So you can see GNOME Sound Recorder is an old application. Well, yeah, it's a relatively old application. Let's see. I was starting GNOME 3.11. Even earlier than that. I wasn't tagged. Initial preview release, so it was started, but it wasn't tagged before that. So the initial commit was in 2013, so it was nearly 10 years ago. It's been ported to a newer version of GNOME. The code base has been updated. It's been ported to GTK4, libad beta. It's been fixed multiple times. It has a long history at this point. but still you can find bugs in there, and those bugs may not be like immediately user visible, but they may be very well maybe some logic issues that are caused by the actual churn of development. So there's always a way to find issues here and there in code, even maintain code. I'm actually wondering, lab sound recorder, yeah, if this has been fixed. I do wonder now, because the port of to TypeScript should have caused the this issue to be immediately visible. So the window here, there should be a close request. Yes. Haha, but it's not necessary here. So application quit is unnecessary. The application will terminate if this the window is closed. And here as well, the application is activated. It should be replaced with so yeah, it's been fixed to a point. Yeah, porting to TypeScript, which is a strongly typed version of JavaScript, immediately showed the issue here, which is there is a virtual function that should return a Boolean value but doesn't return anything, which means that GJS will have to make up a return value on its own, and probably the return value is going to be true because it's initialized, or maybe it's false, who knows. Maybe it's false, and it probably doesn't quit because okay, who knows. And so this application quit was added because something wasn't working right. But this application quit is entirely unnecessary. You just need to return false because the application window will be closed. And once the application window is closed, the GTK application instance doesn't have any application on its own, and it goes away. Actually, maybe it started, I don't know. Maybe there was a reference leak somewhere, so the application never quit. even though there was an application running, because a window was being kept alive. It's entirely possible. So you close an application, but you didn't do anything. But if you activated the application, you launched multiple windows, and then one window was staying alive because something was holding a reference to it, but it was not a reference side GJS. Or maybe the garbage collector was keeping it alive because something was keeping it alive at some point. This is hilarious. It's amazing. A lot of this stuff is amazing because you realize how deep the issues could go, just because of a masked like a mask problem. It's possible a ref leak is still there. It's entirely possible, yes. GJS does try to use weak references in some places. But in this case, the weak reference was held on the GTK side and not on the JavaScript side, because there was an I don't know if the window was actually being replaced or not. I don't know how many people actually tested it by launching GNOME sound recorder multiple times. This is great, actually. This is an interesting puzzle. It needs to be tested, of course, but yeah, never assume that the code is working just because it behaves in a somewhat consistent manner. It could be broken. It could be fundamentally broken. But you don't notice because it's being kludged to death. And maybe now it seems to be working, but it's not doing the correct thing. Okay, so yeah, this is the window here. What do we have here? We have a bunch of model objects and a bunch of widgets that present the view, which is great because this is how idiomatic GTK, like GTK/GNOME applications, should be written. You have a model object that represents a bunch of state, and then you have widgets that connect to properties and signals on the model object, so that you get the view to update whenever the model object changes. And then the model object in this case also subsumes a controller because it has a bunch of API using actions and things like that. So we have a model view controller triangle with the modeling controller in the same object. So instead of, we have a degenerate triangle that is basically just a line, because it has two vertices collapsed into one, which is something that you can do with MVC pattern, design pattern. You don't strictly need to have 3 objects just for the sake of being formally correct. It's a design principle. It's not like a law you have to follow, otherwise the object orientation police will come and will take you away. So the first object here is a bunch of encoding profiles, the recorder object here, which is a G object that has a couple of properties: the duration, current peak. It sets up a pipeline in GStreamer using pulse, audio conversion. It uses the level plugin, the encode bean, and the file sync. Pretty standard fare. If you've if you watch my Amberol like streams, you will notice that there is the level here, which is used for the waveform generation. The waveform widget that Amberol uses is a modified version of the widget that let's call the sound recorder uses. The main difference is Amberol shows the waveform, the complete waveform for your file, discarding a bunch of stuff because the space is limited, and we have the entirety of the waveform for the audio file up front. In the case of the GNOME sound recorder, instead, the waveform is computed on the fly because we are recording. So I don't know if this will work, but if I do this, you will see that the waveform is computed while it's running for obvious reasons. But then it just goes and goes and goes because the middle of the window is fixed. Basically, this is the entry point. The middle of the window is the entry point for my recording here. Then I stop. And here is what's next, what's coming. So it does something like this. Oh, I have to save it. Okay, so I do it like this, and I play it. But if I do this, you will see that the waveform is computed while it's running for obvious reason. Right. So basically, this is a scrolling like widget. And I can do this, and I can grab it and scroll it around. Whereas Amberol has to present the waveform, the complete waveform for the song, and then it lets you navigate through it without scrolling it, because it's an audio scrubber. Basically, you pinpoint the position of where you want to go. Here we are. This is an old, like, it's a problem with GTK4 and GJS, but also it's the warning message is kind of old. Like Clutteractor GTK widget. Yeah. In any case, yeah, this is pretty much the recording does basically, just by looking at it, it creates the recording object. The recorder object creates a pipeline that basically just gets the audio feed from Pulse Audio and converts it to the format that we want it to convert it. We specified in the preferences when we save it, and then also captures the level, the peaks of the waveform, and it saves all the information there into a state object. This is just GStreamer stuff. This is just GStreamer stuff. Just, it's not even using a GST player. It's just using raw GStreamer to basically just get the data out of the input device. that's managed by Pulse Audio or Pipewire in this case, because I'm running Fedora 36. Hi, sorry. Yeah, this is JavaScript. JavaScript through GJS. Also welcome. Yeah. Yeah, basically this is a smaller reimplementation of GStreamer Player, the GST Play object, that only cares about pulling from the input and then updating the position using a timeout here and storing the recording data as a file on disk. Yeah. I mean, I've done the same kind of code for Amberol in my engine reimplementation that doesn't use GST Player anymore, but uses the pipeline directly. It's pretty much like basic GStreamer at this point. Yeah, this is a pretty standard pipeline. Again, it's a pretty standard input pipeline. And all of this gets saved into a recording object. The recording object instead is pretty interesting because, well, it has a name, but also has a duration. Yeah, here. And it saves the peaks that we got from GStreamer into a JSON file and caches it. So whenever you reload the recording from disk, instead of going through the audio file and extracting all the peaks inside the audio file, you can just load them out of the cache, which is also what I do for Amberol. I took inspiration from this. Yeah, you might notice that, yeah, I basically just very much copied a bunch of this code inside Amberol. Ish. It's not really copied because there is a bunch of stuff that you have to do in Rust that you don't have to do in JavaScript. But also, one of the things here is that, yeah, the GNOME Sound Recorder presents you with the peaks, with the entirety of the peaks as they are inside the UI, inside the file, because you can scroll them. Whereas I am not interested in that at all for Amberol. As I said, I even discard like peaks because they will not fit inside the UI. So you can see here there are a lot less peaks than they would be as discovered by GStreamer. Would be a lot longer, would be like completely out of the window. It would draw outside of the window, and it would make like scrubbing to a specific point kind of hard to do. Whereas here I can just click to a point and it will get me there instantaneously, so I don't have to scroll this here and there. Also because the recording could be arbitrarily long, whereas a song is usually a little bit smaller. Also, the code is different in the implementation of the widget, because this is still using where are you? No. Yeah, the waveform widget here is still using Cairo instead of using render nodes like I do inside Amberol. But yeah, I kind of took like liberal inspiration from GNOME Sound Recorder for the Amberol waveform. So I kind of lied saying that I was coming to this project completely as a newcomer, because I had to look at this code. But I looked only at very specific bits of code. I didn't look at the entirety of the code. So but yeah, for the rest is pretty much, yeah, this row widget. It's kind of easy to get into this code base. It's very well split, very well separated. Every file is a single like object or a couple of objects tops. They are very much related one with to one another. It's very much a good code base to, I'd say, almost copy if you're writing your own JavaScript application. Of course, if you're writing your own JavaScript application, you might want to wait a little bit until the port to TypeScript and the refresh for the idiomatic code has been updated, because has been merged, because right now this is how you would write an application in JavaScript in 2020, 2021 tops. There is more idiomatic GJS coming in the next cycle, so caveat emptor. But in general, yeah, if you want to learn how JavaScript applications are put together in GNOME, this is a great example. You can take inspiration from this implementation because it's very well made. It still has bugs, but it's very well made. So, okay, let's close here a little bit, because it's getting late for me. And I'm also going to evaporate if I don't move outside of my office. Hey Quinn, where can I see the programs to develop? In this case, I'm looking at GNOME Sound Recorder, which is one of the GNOME core applications, I think. As far as I know, yeah, it should still be a GNOME core application. This is hosted on gitlab.gnome.org. It's not developed by me, but developed by other people in the GNOME community. Let me see who is the maintainer. Meg Ford. She's she's the author of the application. Then we also have Christopher Davis and Bilal and Felipe working on it. So this is where you will find it. If you want to find it online, it's going to be here. There we go. It's not in core. Okay. Oh, it's probably in circle. Maybe. I honestly, I'm technically in the release team, but I don't remember everything. How will the TypeScript work? the TypeScript gets converted at build time into JavaScript. The as far as I know, it's still a merge request. It's still a draft. As far as I know, here, yeah. But basically, what it does is, yeah, the build just, let me see, inside the meson bit, yeah, it runs TypeScript compile. It compiles then into JavaScript, and then JavaScript gets executed by GJS. GJS doesn't understand TypeScript, so you always have to turn TypeScript into JavaScript. The one thing that is very useful in this case is that the TypeScript comes with a bunch of type definitions here that are generated by, I honestly don't know. They are probably generated by some tool in the GJS community, as far as I know, that basically generates the TypeScript type information out of introspection data. Christopher pushed the types because it's probably hard to build or takes too much time to build during the actual build process, or probably requires a bunch of additional dependencies that are not very nice to package into a Flatpak. I see here in the build that is using yarn. Yeah. But yeah, if you one of the changes that he has done as a precondition to the port to TypeScript is changing the code base to use the import from syntax instead of using imports.gi and imports whatever. So it's using the this syntax here, fake URL. Which is an interesting choice by the JavaScript devs. Or here, like a version GTK import is GTK question mark version equals like a fragment in a URL. Oh, my machine is running really loud. It must be getting hot inside there. But yeah, if you look at this, the TypeScript definitions for GTK are like 20,000 lines. So it's gonna be a pretty big ask. Like, let's see, graphene here. I don't even know if it will render correctly. Yeah. So yeah, all of this stuff is generated by the introspection API. Yikes. Okay. GitLab is going to die. Oh. Music too loud. Anyway, yeah. Yeah, I think this is a good place to stop. But basically, the overall idea is that if you are blocked by the choice, if you are blocked by, if you want to contribute to GNOME, but you have no idea how to do, what to do, and how to start, or you're blocked by that, then my strong suggestion is just launch GNOME Builder, look at the suggested applications there and clone them and just read the code, and you'll probably figure something out. I want to sell your software in China. You cannot sell my software. I mean, technically speaking, you can sell free and open source software, but it's probably not gonna work. But yeah, you can do that in China. Should be fine. Just make it clear that the licensing terms are usually in this case, well, in the case of GNOME Sound Recorder is GPL2, so the requirements are for you to always provide the source code to whoever asks. But yeah, basically, if you have a writer's block, if you are paralyzed by choice, then open one of the projects in GNOME that are listed in GNOME Builder, look at them, clone them, just explore them and see how they're put together. Just break them apart, figure out how to put them back together. It's not necessary to start from a blank slate most of the time. I know it's daunting sometimes to be confronted with a completely empty text file and then start programming. It's just don't do that. Don't start from that. Start from an existing application, read the code. Read it like you would read a novel. Just start from how it's put together, so the directory layout, the build system, and then find the main entry point and follow it like you would follow a map, or like a choose your own adventure kind of book. Basically go through it, follow how the objects are put together, who calls what is the lifetime of each object that is instantiated, and then presented to the user. Figure out if the application is built that way. You can figure out which are the model objects and which are the view objects, and you start from the model and you figure out what are the exposed properties and what are the signals that are emitted whenever something changes, and try to match the changes that are propagated to the view. And then you take the view and look back at what happens whenever the state object changes. If an application presents multiple state objects, look at if there are list model implementations, or if it's just using a list store, and then look at the view that represents that list. Break it apart, look at how it's built together, and then reassemble and see if it still works. And if it is, you understood how it's put together. And at that point, you can start applying those patterns to your own application. Start designing your application in terms of that particular design. So if you are, again, looking at a way to start contributing to GNOME, don't start by, oh, I want to create this application. I've seen these amazing designs. I want to implement them, but I have no idea how to start. or I haven't found a tutorial, and that means that I have no idea how to start. If you have the code for an application that you're already using, or if you already know a language and you want to look at how things are put together, open an existing application. It's why we release the code in the first place. We don't release the code because we are great humanitarians that we enjoy imposing our code, like spreading our code far and wide for no reason whatsoever. The reason why we put the code out like in the public for everyone to look at is because we believe, and I know I'm like talking about the entire GNOME community here, so take that with a truckload of salt, but I think for basically everyone in the GNOME community, we publish the code not just because it's the right thing to do, but also because it allows other people to learn how to program, teaches other people how to contribute to the GNOME project, and it improves the ability of other people to come together and create something. And yeah, we enjoy making others suffer trying to fix software. Yes, of course, we suffer. Of course, we are suffering, and we enjoy spreading the misery around. That too as well. I mean, it's computers. Computers were a mistake. Always have been a mistake. And in order to spread the misery far and wide, then we present everyone with our code, and we trick people into contributing upstream so that other people will be able to maintain the code when we finally give up and go back to agriculture or wood making or anything else except having to deal with computers. Which is something that happens far too often. God. Anyway, I hope you enjoyed this adventure inside the GNOME Sounds Recorder code base. Hopefully, if you ever find yourself stranded in the middle of a GNOME project, you will know how to find your way back. Otherwise, just join the Newcomers channel on the GNOME IRC or Matrix server. Start from the Newcomers wiki page that you see small, where is it? Here, probably. And then from there, just explore. Don't ask for permission. Don't try to figure out documentation that doesn't exist. Though I do hope to be able to write more tutorials in the future, because I think they are important, they're useful, but don't expect a tutorial to write an application. That is never gonna happen. I wrote the getting started tutorial because that is basically the most complex tutorial possible. You will find tutorials for very specific topics, but other than that, you will probably have much better luck opening an existing application and figuring out how it works. So as I was saying early in the stream, the next few weeks are gonna be kind of tricky for me because I am currently nursing my partner who had surgery on Friday, which means that, yeah, at the very least the next couple of weeks I will be probably going to be doing streams like at random times or at random days, not like a strict schedule, and hopefully will be over by the end of the month. So just follow me on Twitter, twitter.com/Abassi, or follow me on Twitch, twitch.tv/Abassi. You will get notification every time I start streaming. If I'll try very hard to put the VODs on my YouTube channel, so if you want to catch up with what I've done asynchronously instead of like during the stream, then follow me on YouTube and press like and subscribe on my YouTube videos. It's usually helpful to basically appease the algorithm to which we are all beholden to, and the mammon we have to appease in this the darkest timeline. Anyway, thank you for following me, for following on. Oh, thanks, Georges. Yeah, they're gonna be fine. It's gonna take a few weeks to recover from surgery. They're already pretty much okay, but they have limited movement at the moment, so which is why I'm, of course, helping out. Anyway, thanks for watching, and I shall see you soon. Bye.